Okay, let's start. This is Cfrg, Alexei Melnikov, Nick Sullivan, and Stanislav Mishlev. So we have 2 hours, quite a busy agenda. So let's start. We have a minute taker. Thanks a lot to Richard. And we'll start with the Cfrg update, and Nick Sullivan will do the presentation. Please, Nick.
Thanks, Stanislav. Just setting up the screen. You have to unshare yourself so I can share the slides. Great. So welcome, everyone. This has been long IETF, and welcome to the last session of the whole event. So if folks aren't aware, this session is being recorded. There is a minute taker in CodeMD. Thank you, Rich Sauls, for doing so. Jabber relay, the Jabber should be connected directly through to the chat. So it should be all integrated. If there's something in Jabber that doesn't end up there, please raise it in the chat. Here's the participant guide. Blue sheets are automatically generated. So if you're logged in and you're in here, you're in the blue sheets, nothing manual to do. This should be all familiar. This is the last meeting. Here's the note well. This is the IETF IPR disclosure rules. This is the same one across all of the IETF and IRTF. Every meeting you've attended should be the same. So everyone should be familiar with this. If there is IPR, please raise it. And the details are here. We also have a code of conduct in the note well that everyone should be familiar with. We have a great ombuds team to deal with anything that comes up. Take a look at these 2 RFCs for more details. As a reminder, some goals of the IRTF and how it differs from the IETF. IRTF is interested in conducting research. It's not a standards development organization. This Cfrg may seem to straddle the line there, but it's very much on the IRTF side. Cfrg produces informational documents that are very useful for the IETF. But if you want to know more of the differences, follow this RFC. And with that, we will jump into the overview. So here is the agenda. Does anybody have any agenda bashing? This agenda should be published online, and everyone should have seen it before. Going once, going twice. Yeah, we'll step through this all the way through. We've got a very packed agenda, so please, presenters, try to stay on time. We'll be using the clock meet echo mechanism to give you guys everyone here who's presenting a counter. So first, research group document status. We have quite a few active ongoing documents here in the group, and they are in various states. So first, Argon 2 is in the RFC editor's queue. IESG review, nothing. The IRSG review, we have HPKE, which we'll have a quick update at the very end of this presentation about. SPAKE 2 is on draft 20. This is updated, and the research last call is done on this. Active drafts, we'll be going over quite a few of these in different presentations, but here are the active ones. Hash to curve, VRF. We had our first research group last call for VRF. Not enough responses to get that going. So take a look on the list. If you're interested in VRF, there should be something on the list coming soon about potentially a second research group last call there. Kangaroo 12 has been updated after the second research group last call. VOPRF updated, AEAD limits updated. You'll see an update on both of those. Opaque updated. CPACE, we are on draft 1 here. All 3 of those will see updates in this meeting. Frost is unchanged. RSA blind signatures has recently been adopted, and we'll see a presentation about that. Some of the adopted documents that are newly expired and need an update here include pairing friendly curves. which has been updated but is currently expired, BLS signatures, and Ristretto decaf. Expired drafts, these are the ones in the queue, the ones in the list that are not newly expired but that were expired last time. Another quick update here is for the erratas. We've had several erratas that were opened over the last couple months, 3 of which have been verified since the previous update, and a number of new erratas have been opened. And so these are in the queue for the chairs to validate. It's mostly against 8032 and 8435. And with that, we will, I guess, continue with the rest of the presentations. Here again is the agenda. Again, I want to open it up again. Any other agenda bashes? Otherwise, we will hand it over to Dan Harkins. Dan, if you want to present your slides.
Okay.
Before you do, Chris has stepped into the queue. Chris?
Yeah, just had a quick question on the Ristretto doc. Do we know what the status is on that? Are there any like blockers in moving it forward or open issues or anything?
There hasn't been any update on the list, and the document itself hasn't been moved over to the Cfrg GitHub page, so I'm not aware of any blockers or issues.
All right, thanks.
Okay, so I'm asking to share slides. Do you guys have to do something now?
Yep, I just unshared mine, so you can.
Then I think you'd better share the video screen, not the slides.
All right.
Yes.
Yes. The object cannot be found here, it says. Tell me if you're seeing slides.
But I'll happily share.
Share the screen. It can be easier.
Yay or nay?
Can you see the slides?
Yes, can you see my slides?
Okay, then just tell me the slide each time when you want to change slides. So please start.
Okay, all right, thanks. So next slide, please. So I really like HPKE. I think it's great. It's very well defined and it's complete. But like with most effusive statements these days, it's qualified. So one of my qualifications is it has some bloat, and that's when using the NIST curves, it uses the SEC uncompressed form of serialization, which makes the public key more than twice as large as it needs to be, which could be a problem for constrained environments where every bit counts, or it could be a problem with people who want to use the HPKE API in a one-shot manner if they're using a short message, because that would result with the message is going to be dwarfed by the overhead necessary to make the call. So what I want to do is, if we can observe that HPKE uses what RFC 6090 calls compact output, where the Diffie-Hellman shared secret is the x-coordinate of the elliptic curve point that gets derived as a result of the ECDH function. And if the sign doesn't matter for the secret, then it doesn't matter for the public keys that went in to create the secret. So we can represent the public keys by their x-coordinate only, which is what RFC 6090 calls compact representation. Next slide, please. So here's an example of what I'm talking about. So the top one is the serialization of a key with SEC uncompressed, and the next one is a key using 6090 compact serialization. So the gains are pretty impressive. Next slide, please. So my other qualifying statement for my effusive statement is that HPKE assumes guaranteed in order delivery of packets. And that's because the AEAD ciphers that it defines all take nonces, and the nonce management is entirely inside of the HPKE context. So that means that if you receive a a packet, you have no idea what the nonce was used to encrypt it, which wouldn't be a problem with guaranteed in order delivery. But if there is loss or reordering, then things are going to stop working pretty suddenly. And there's no way to resynchronize the contexts if they do get out of order. So it's basically a tragic occurrence, which again won't be a problem if you have guaranteed in order delivery, but that's not the internet. So next slide, please. So I want to fix this, but I don't want to change the HPKE APIs. I think it's good that users don't pass nonces through the APIs. I think it's good that they don't have to care about the nonces. I just want to make sure that in the event of loss or reordering, that things don't become tragic. And the way to do that is to add cipher modes that support deterministic authenticated encryption. So with them, there's no nonces to worry about. So each packet can be decrypted without having to worry about any sort of external data in order to decrypt it. So I know that there's at least one of you out there thinking, well, why don't you just export a key from the context and then you can do any cipher you want outside of HPKE. And the reason I don't want to is because I like HPKE, as I said at the start. I think it's really cool and I want to use it. And I don't want to reduce it down to just a static ephemeral Diffie-Hellman key exchange. If I wanted one of those, I would, of course, use one, but I want to use HPKE. Next slide, please. So I want to add some DAE ciphers, and there is a security. There's a paper that talks about deterministic authenticated encryption. It's this Rogoway and Shrimpton paper referenced here from Eurocrypt in 2006. It has a security proof if you're into that sort of thing. It talks about deterministic authenticity and deterministic privacy, and then it has a combined all-in-one notion of deterministic security. So, briefly, the notion of authenticity is that the adversary is unable to produce a non-trivial forgery, and for privacy, it's that the adversary is unable to determine whether the output from the oracle is the message he sent or it's random bits, and he's barred from doing the trivial way of figuring that out. The trivial way, of course, is to ask the same query twice. Because, as the name implies, this is deterministic, so we can't conceal whether a given plaintext AAD combination was encrypted twice in a sequence of ciphertext. So this is a different security guarantee than the existing HPKE authentication or AED modes provide. So there are some security considerations to think about. For some use cases, this won't matter if the messages they're encrypting are idempotent, or they can figure out how to handle replay, or they just want authenticated encryption in their lossy medium. This should be fine. For other cases, if they're able to add something new to the message, they can get around this issue. So, for instance, if you're some sensor and you're sending out some environmental recording every minute or something like that in your lossy network, you could, for instance, put the time since epoch in the AAD, or if you wanted to be fancy and get privacy, you could put time since epoch as a tweak into the plaintext. And this is because of the notion that if any bit in the AAD or the plaintext is new, then the synthetic initialization vector that gets created as part of this cipher mode will look random, and therefore the output from the encryption will likewise look random. So, of course, if these security considerations are not applicable for you and you still have a lossy network, you could, of course, use the HPKE APIs in the one-shot mode, but that would be very wasteful and kind of a pain in the ass. So I think this is a reasonable approach to obtain resistance to packet loss and reordering. Next slide, please. So I don't want to change anything in HPKE. I just want to add some stuff to it. And what I want to add is some new chems that do the NIST curves with compact output. And I want to add 2 modes of AES SIV, which is defined in RC 5297, in the deterministic authenticated encryption mode. So there's no nonce used and there's no nonce generated. Next slide, please. So I did write it up as a draft, and this is the draft here. Please take a look. In the interest of running code, I did implement it. I added it to my implementation of HPKE, which is compliant with version 10, the latest and greatest. So my code can pass all the test vectors for HPKE, in addition to compass test vectors that I've created that implement the compact representation and the DAE ciphers. So that's the running code. So in the interest of rough consensus, I'm wondering if there is interest in adopting this draft as a Cfrg work item. End of slides.
Yes, Chris?
Hey, I think this is a really interesting idea. I really worry about different code points providing different security properties for the user. And if you want, like, so I mean, so the generalization of DAE is like misuse resistant authenticated encryption. And they're like, you're as long as, you know, as long as something, one of the inputs, as long as one of the inputs varies across encryptions, so like you can, as long as, if your nonce stays the same, but your AD changes or your message changes that you're encrypting, you get standard IND-CC82 security. So I feel like this is going to just end up pushing the task of making sure inputs are unique to the AAD in the HPKE interface. Thank you.
Yeah, so that's what I'm trying to address, that if that is a concern, then you would probably have to try and either add it as AAD or add it as a tweak in the plain text. But not all uses would care, for instance. But if you do, then I'm just trying to give a way to use HPKE in a lossy network, which we don't have today.
Thank you.
Can you go back one slide? Or one more slide. Sorry, I'm going to try to raise my volume here. So the second bullet in that implications section, which is like, make sure you're including something new. I mean, I think this is similar to what the previous speaker was concerned about, but this smells to me like sort of the rough equivalence of putting the nonces, you know, passing around the nonces of the packets, which the slide before this seemed to say you didn't want to do. So it seems to me like I'm not really getting, like, I'm not getting the rationale here. Either we say this is for folks who really do have idempotent messages, that top bullet, right? Who don't care about that, in which case it's a strange thing to say, yeah, we want to do this thing that is worse than what we know how to do. But saying, or you could probably get roughly the right thing by making sure you have something new in each message. We hope you'll figure out what the right thing to do is there, seems worse to me. Like, why are you including this additional case when we have formalized variants that should handle it otherwise?
Because those require guaranteed in order delivery of packets, and if you're able to
well, but they don't require guaranteed in order delivery of packets. If you include you know, a truncation of the nonce that is, you know, truncated enough that your out of order delivery, you'll be able to tell where it lands in the window.
Right. So that is possible to do if you are able to produce a verifiably unique nonce with every invocation, then you can include that.
Well, it doesn't even need to be verifiably unique, right? I mean, if we know that our nonces are being measured, you know, that we have large nonces and all you pass is like the low 8 bits, then, you know, you can try the most recent epoch, you know, in that 256 cycle, and you're probably going to hit it unless your packets are way out of order, in which case you try the next one, you know, 256 up or down from there. But it's not, it doesn't seem like it's a huge, either we're asking people to make up their own effectively nonces and ensure that they're accurate and have all these properties that we expect, or we just give them a system that says, here's how you do it. And I'm not sure I understand why. if you want to argue that this is good for idempotent messaging, then I would probably agree with you on that. But if you're saying, or you can use it if you don't have idempotent messaging, just make sure that you do something to make it new, that just strikes me as a very fuzzy thing. It's like rope to hang ourselves with.
So right, you're adding something new, but the packets can still be reordered or lost, and you're still able to decrypt a packet in C2, which you're not able to do with HPKE now. And the way to get around that, if we wanted to require people to add nonces as AAD, it would require us to change the HPKE APIs, and that's another thing that I really don't want to do. I kind of like the way that they are, that you don't have to care, you just go. If you care, then I guess I'm selling a gun, and if you shoot yourself in the foot, then you shouldn't have pointed it at your foot and pulled the trigger.
Martin?
The least appropriate analogy here, I think. I agree with DKG on this. I think that there's probably a case here for modifying the HPKE interface so that you could, say, skip or take the messages out of order. I think you've made the case for that reasonably well, I think. And that would be the model that DKG is talking about. And I have less opinions about the idempotent deterministic encryption thing, but this sort of middle ground where you use deterministic doesn't seem sensible to me. It seems like it's more dangerous than it is.
Any other comments, questions? I think that we can take it to the list because there can be some new opinions. Thanks for them.
Thank you.
So we have the next presentation, a duck test for end-to-end secure messaging. Alec, please. Yes, I'll grant you the screen. Yes, we see the slides. Please start.
Hopefully you have audio now. Hello, good evening. Does this look okay to everyone? I'll go with yes. Okay, hello. I'd like to talk about a duck test for end-to-end secure messaging, draft Muffet end-to-end secure messaging 03. What is this internet draft about? It's about end-to-end secure, including end-to-end encrypted messaging. This is something which I'm sure we all already understand, but my thesis with this internet draft is that our intuitive and slightly differing understandings are no longer politically fit. They do not help us in technical policy-related debates. And so I would like to address this specific problem. That is, well, there's a saying in business that if you want to change something, you first must be able to measure it. Therefore, if you want something to not change, you must also be able to measure it in order to determine that it has not changed. And there are a lot of people who want to change end-to-end security. 3 examples, for instance, include UNICEF, who are, in a recent paper, were discussing the potential benefits of detecting abusive content that was being shared over end-to-end messengers by putting filters on people's devices, on people's clients. There's GCHQ, who a couple of years ago posted the Ghost proposal, where they would like to have an invisible participant spliced into all end-to-end encrypted conversations. And there is the Indian government that wants, for instance, in this case, WhatsApp, to keep a hash of the plain text of all messages that pass through it in order that they can determine who it was who first shared some piece of content that they find offensive. So there are a lot of proposals, and uniformly, all of them say they do not break end-to-end security. They are just adding extra protection. How may we test the assertion that they do not break end-to-end security? One possibility is that we could try and define end-to-end security, end-to-end encryption, by saying what algorithms do we expect it to deploy, what features do we expect it to have, who are the actors, who are the people who will be using it, and what will the expectations of those people be. And this is very much the method being employed by draft nodal E2E definition. It's another internet draft. It's got potentially complementary goals to this one, and it specifically is looking at end-to-end encryption rather than more narrow as I am messaging. The draft as it currently exists is quite large, and it's challenging to use as a test because of its top-down nature. It's declarative nature based around expectations. For instance, if we look at section 4.3, it makes commentary about private communications which are intended to be sent to intended recipients without making explicit the fact that the recipients are the ones who define the intention, as opposed to, for instance, in some other interpretation, law enforcement deciding that they should be intended as well. It also talks about formally interfering with channel confidentiality as being some character of the management of the data as it passes through the algorithms and the systems. I don't actually know what that means. I posted it to Twitter and I wound up with 5 or 6 different interpretations, 2 of which interpreted it as a means to enable legal access, legally permitted access. And then there's also the matter of it being reliant upon expectations and violation of these expectations without actually saying what the consequences of violating these expectations are. So I'd like to propose an alternative, which is rather than whether it looks like end-to-end secure messaging, does it quack like end-to-end secure messaging? And so we have to develop a test for end-to-end secure messaging. And there's fortunately 3 really big hints in the name. Firstly, it's got to be end-to-end secure messaging. This implies that there are ends and we should respect them. For a first cut, I will just sort of say ends we will assume are participants, which might mean a sender or a recipient. Secondly, it's messaging. And by messaging, what I mean is a system where each individual message, the sender composes and sends, dispatches, and at that point is frozen into it a complete and immutable set of recipients whom the message is readable or accessible by. This is distinct from, for instance, forum-type software where new joiners in a group would be able to look at retrospective previously sent content. What I'm getting at here specifically is forward secrecy sort of things. But as a surprise plot twist, we then define recipients not as critical participants. What we do is we say a recipient is any entity that can determine one bit of plain text with more than 50% certainty. And the reason for doing it like this is that one can then say that if any recipient was not known to the sender at the point of message composition or sending, the system does not implement end-to-end security. That's it. That's the whole test. It's there are some sort of contextual things which I'll get into in a second, but it's very simply a falsifiability test. This also provides us an obvious definition of backdoor. A backdoor is any mechanism which leaks bits to a non-recipient, irrespective of whether it is intentional or unintentional. It's basically the logical inverse of a recipient, a legitimate one. It also means that we can do surveillance or management or moderation or helper bots or compliance or something like that, so long as they are overt participants rather than the GCHQ ghost scheme with invisible spooks. What we actually wind up with is GCHQ evidently being there for your own safety or your local police force or whoever it might be, the platform safety team of the platform that you're using. Just so long as it is overt, it's fine. Nitpicks and edge cases. I'll go through these really quickly. Firstly, there is some metadata which is sensitive and needs to be protected. For instance, content length. We should protect it. Secondly, there is some metadata which regrettably is outside of the scope of protection or just hasn't been implemented. That's kind of okay so long as it doesn't leak anything about the content. It's an old problem, thematic metadata rather than descriptive metadata. Thirdly, encryption of the messages is not actually necessary. some growing set of new messenger solutions don't actually do content encryption. They don't encrypt the messages. This is why we call it secure messaging rather than encrypted messaging. Things like Ricochet, which just pass messages direct point-to-point over, admittedly end-to-end encrypted Tor onion network links, but they don't bother with message encryptions, which makes it somewhat distinct. Fourthly, the set of recipients varies between centralized and decentralized solutions. This is a technical nit for when you're using something like email or Ricochet, you as the sender is the person who defines who the recipients are at the point of composition, literally. When you're using something like Signal or WhatsApp, there is a shared context of group membership, and that is what gets used to generate the set of recipients. 5 groups should not be allowed to have people injected into them. They should be enclosed unless they open themselves up for public subscription. 6, you can cut and paste and forward and quote and cite old messages. This is an exception to the fact that you can't see retrospective content. If it gets re-upped, reboosted, then yeah, you'll see it. 7, this is a technical nit about self-referentiality, which is that if a participant is also a platform, they have to not cheat. If they have a MITM capability to see plain text without acting as a participant in the protocol, they're cheating, and that's wrong. And then 8, finally, this is the big question. End actually doesn't just mean participant. It means trusted computing base. If people are old enough to remember the Orange Book, it's actually the set of systems which the user deems are in their trusted path, are things that they can rely on and depend upon. There's a marvelous paper which goes into this from 2011 by sorry, I forgot the names for the moment, Clark and Blumenthal, called The End-to-End Argument and Application Design, the Role of Trust. It's a fantastic paper and talks about trust zone to trust zone being the model for end-to-end going forward. And I'm surprised that it hasn't been referenced more in other research. This means that when Alice accesses her messenger over RDP, it is not a failure of the end-to-end security. If Bob has a hacked app, it is not a failure. If Carol's phone storage is forensically analyzed at rest, it is not a failure. If Dave's keyboard or grammar app is leaking the keystrokes to local authorities, that is also not a failure. These are all part of the trusted path, or they should be, and we've got a lot of collateral which helps us understand this concept. Although the debate about these topics, especially regarding China and Android keyboards and so forth, does continue today. Also from that paper, I am delighted to have rediscovered RFC 2804, which lays out the IETF's position about wiretapping, that the IETF does not consider requirements for wiretapping as part of standards development. And that's great, even though we are now moving from a world where wiretaps were done centrally to where they are being emplaced at the ends on client devices. It's not something for us to worry our heads about. We should focus instead on delivering standards regarding what is and is not, or how things should work. Where I would like to go with this test is I would like to go for CFA. I would like to get it accepted and then refine it through rough until we achieve rough consensus, get it thoroughly battle tested, and ship it as an RFC, not the RFC, but one falsifiable test for assertions regarding the end-to-end security of a system. And anything that fails to meet that test would just be not compliant with this RFC. There may be other RFCs, there may be other tests. I'm content with that. And then the goal of this overall is to inform user choice and assist clarity in policy discussion and in design of new systems and so forth. I think that's all of my slides. So thank you very much, and I'll take questions.
Thanks a lot, Alec. I think we have quite a lot.
Yeah, so
I'm
in favor of working on this. I do have a few, as somebody who's producing one of these systems, I would like to have it defined in such a way that my system qualifies and other people's don't. In particular, the thing that's got me concerned about most of the end-to-end systems out there at the moment is they're proprietary systems where the operator controls the PKI and the identity infrastructure. And so if I'm sending information to Alice or whatever, they provide me with the client. And there's no way that I can protect myself against them giving me a bongoed client that redirects the stuff to Mallet. And it's not clear, that's the sort of thing that I would like a test of end-to-endiness to be able to detect. And I'm not quite sure that your trusted computing based thing excludes it.
I am delighted to look into issues like that. From my experience working on RFC 7686, where I was very much an author under the tutelage of the inestimable Mark Nottingham, I learned that it was much more simple and much faster to put 5 RFCs through IETF, each of which does 2 things, than 1 RFC that does 10. And so I've sought, following that experience, to narrow the specification, what I'm targeting. And I'm targeting it specifically to messaging systems as I have defined them and attempted to capture PGP, Signal, WhatsApp, Ricochet, Briar, Wicker, and things of this nature. And I'm trying to avoid scope creeps so that it's possible to ship this within a reasonable time. This is not to exclude the possibility of taking it forward and expanding it. This was mentioned by, I think, Martin in an email last night, or maybe I've misremembered that, I'm afraid. But
my concern here
I'd like to be able to sort of expand it once we have got a foundation stone.
My concern here is actually Signal and Telegram. I think that the authorities can come along and say, you're going to put this code in, this backdoor in for us. I've got no way of testing it. And so it's more sort of like, as the user, what do I have control over? What's the scope of trust and force?
It's regrettable that I've had to cut this deck down, because the previous version of the deck that I submitted was a little bit too large, and Stanislav asked me to reduce it a bit. I had reference to reflections on trusting trust in there for this reason.
We have an additional discussion, so we decided to add 5 minutes to this discussion, so let's continue. Please, Matthew.
Yeah. Hi, Alec. It's Matt. So my concern is that you're choosing a new name for something that the rest of the world already associates with end-to-end encryption. And a lot of the content you have is really quite good. And I think it provides a much clearer and conciser description and ability to make a decision as to whether something is secure. But I think it would really benefit the E2EE draft to really to incorporate a lot of what you've done here into that draft, to really take a more general view of it as well.
I can see where you're coming from, and it's something which I wrestled with last year in the early development of what was a Medium post at the time before it turned into this. Whether it should be E2EE or E2ESM's secure messaging. Ricochet was the thing which twisted it for me, that the messages are not encrypted. So calling them end-to-end encrypted seemed odd, even though you and I both deeply know that this is going over Tor and that there is end-to-end transport encryption. But if we start looking at transport layers, then we could tie ourselves up in knots by saying, ooh, is Signal running over Tor the same as Signal running over non-Tor, because we have changed the transport? It's a layer boundary issue, which I think is, maybe I'm just being overly uniform, being a little bit anal about it. But I think it's clearer this way. It's regrettable that there's diversity of opinion, maybe, seeing as we are trying to build various standards, but this is just a test to achieve a specific goal, and I have not yet come to the sensation of there being actual consensus to land with. Maybe this is part of the discussion we should be having during the development of this as a draft.
Okay, that's fair. I think specifically for Ricochet, it's not secure unless you have that underlying layer. So I think
it is,
and
from my previous existence at Sun Microsystems PS, I have seen systems with extremely secure networks implemented by burying 6 foot of armored conduit under a London major road, and no encryption either end because of latency. It turns out you don't always need encryption to achieve it, although it's terribly helpful.
Thanks. Martin?
Yes, Alex. I agree with Matthew about the scope. I do think this applies to the Ricochet exactly as you have proposed it. I think it applies to a number of different protocols exactly as you have proposed it. And using end-to-end encryption as the thing that you're attempting to define would be far more useful than trying to come up with a new term, because that's the term that people use.
I'm very sympathetic to this, but it's also to paint a large target on this draft to cause expansion of the scope, and that would mean several months, possibly even a year or two in discussion.
Oh, you're there anyway. Sorry. That's just how these things work, unfortunately. So
I see. I'm still scarred by the experience of 7686 and being berated for having taken a very large draft that tried to register many domain names and cut it down to just .onion.
Yeah, I think in this case that would be necessary, and I also would like to have this happen in the IETF rather than the IRTF.
That's something which I'm open to
valuable.
discussion on that, but I was taking sort of some advice from Rich and a few other people, and I'm open to sort of discussion about this. I don't know where it should land myself, but looking at the charter of CFRG, the idea of shipping informational RFCs in the tradition of RFC 1321, our goal is to provide a forum for discussing and analyzing general cryptographic aspects of security protocols and offer guidance on the use of mechanisms. And I'm just thinking that actually sounds like a pretty good fit.
Thanks. We'll have to close the queue after Daniel. Please, Daniel.
Thanks, Alec. I appreciate the talk. Good, clear thinking. And I like the fact that you made it focus on a test. I think that's useful. As far as the Ricochet versus the other messages, I think what you're pointing out here is just that store and forward versus online connectivity is irrelevant to the definition. And I think that's fine. I think it's a nice property that falls out of the way you defined it. My concern with the term end-to-end encryption is that it doesn't encompass all the other cryptographic properties that we want besides encryption. But I'm also aware that the term end-to-end encryption is out there in the world and is widely used by non-specialists to mean all of the things that you're talking about here. And I think I agree with Martin that it's better to just embrace it and redefine the term, if we're redefining it at all, to where it captures the authenticity and confidentiality notions that you've included here. So thanks. I'm positive
I am open to this idea. I'd like to see some degree of acceptance in turning it into a draft rather than faffing with it beforehand. Not least because I believe we're time critical, looking at some of the pressures being brought by various governments around the world.
Thank you. I would say that we will take it to the list, but it's already in the list, and the discussion is started. So thanks a lot, Alec. Thank you. And now we are going to the status of the current drafts, starting with BOPRFs. Armando, please share your screen.
Hello, I'm just sharing the slides. 1 sec.
Yes, this is slides. Please start.
Okay, hello, my name is Armando Faz. I'm going to present the status update of the BOPRF document. Yeah, so first of all, this is a brief reminder about what OPRF is. This is like the oblivious computation, the computation of the oblivious of the random function. Basically, this is a two-party protocol where the client interacts with a server in order to compute a pseudo-random function under a private key that is held by the server. So there are two main properties for this protocol. We want that this interaction be oblivious in the sense that the client can only learn the output of this PRF without learning anything about the private key of the server. But at the same time, we want that the server doesn't learn anything about the input that the client provides, doesn't learn about the output of the computations. So yet another property other than this basic mode is achieving verifiability, in which the server, in this case, needs to commit to the key that it has, and gives to the client a proof that actually the PRF was computed using this private key. So in that case, the client can after verify that this proof actually holds. Well, with this in mind, so what is new from the latest version of the draft from the previous meeting? So basically, how does the server compute this PRF? There is a blinded mechanism for the client in order to send the information in order that hides that information. So there are two main methods for blinding this information. One is multiplicative blinding or additive blinding. Multiplicative refers to where the client tries to multiply using like a scalar multiplication in the group, and then it can hide this information, or is additive, it only adds another point. So in the previous meeting, where there was raised at this point whether it was secure to use additive blinding, or on what are the conditions in which this can be used. So we arrived to a conclusion, so in which the verifiable mode, they can use additive blinded, which is still okay to use it, provided that the key was commuted, and this is a secure way to do it. This doesn't happen on the basic mode, and in this case, we need to use multiplicative blinding. Some other changes or updates on the draft was we are having more explicit definition of the errors that the protocol can encounter. For example, the deserialization of objects is something that can trigger an error. So we updated some documentation on some API considerations. Another point that has changed is that we adopt the Shake 256 for the CAF 448 cipher switch, because usually they are these two pair of algorithms it's common to find paired together. We also have this generalization of the zero knowledge proof, double discrete logarithm equality, and then this can be useful for other protocols. Finally, we update test vector and made some editorial changes. With this in mind, so they're reminding what issue related to metadata, and for that I invited Sophie Selig, which will be explaining us what is this new approach about using metadata in BioPRF. So Sophie, hand it over to you.
Thank you, Armando. Next slide, please. Yes, so right now there's a proposal, a pull request open against the draft in the GitHub repository, how to add public metadata into the protocol. Why will we want to be adding public metadata into the underlying primitive is because certain applications of the BioPRF are trying to use metadata in order to prevent certain attacks, or in order to solve certain implementation bugs that might exist. So the proposal to actually add public metadata into the BioPRF is called a BioPRF, and it has defined in this paper that has been recently published over ePrint, and you can read it if you want to find more information about that construction. It uses the same specific functions for the API as the BOPRF, as you can see here. The only other thing is that you add metadata, but in this case of this graph, this is labeled as T. You add it to the blinding function, you add it to the blinding function, but don't really use it in the other operations. The operation of the blinding function remains the same. You add it to the blinding evaluation function, or evaluation as it's called in the protocol, and then you do 2 different operations, because you add the secret key to the hash of the tag, and you also use this to invest and exponentiate to this new value. And then the last function, which is the unblind finalize, that is defined as verify, finalize, or finalize in the current status of the draft, also uses a new operation, because instead of raising it to the R, you raise it to 1 over the R. The verification and zero knowledge proof that is used for the generation of the proof and verification of it is not changed. The only difference is that you pass just a slightly different parameters. Next slide, Armando. Thank you. So from a protocol perspective, this is how it looks like. The server and the client input their own metadata. This metadata can be of any length, and it can be optionally added by either the client and the server. Currently, how we have written in the PR for the Cfrg draft, it is that even if the client or the server don't add the metadata, it's completely fine, because there's the mode in which no string of metadata is added, and therefore an execution of the protocol runs without this metadata. So it's not bounded for you to having to add metadata. So as you see here, the server and the client will be the ones adding the metadata. Either party can add, or neither of them can add. Next slide, please. And just to give you some a small consideration, so the consideration of what I already said some time ago is that the metadata can be of any length, but this should be actually considered by any application that is going to be using it. So yes, it's bounded. It's not bounded to any limit of size, but that probably has to be taken into consideration for privacy reasons and also for usability reasons. And as I said, metadata can be added by either the server or the client, or both. And how the server and the client determine what kind of metadata to be added is something that can be done outside of the protocol itself, or it can be sent alongside during the protocol execution. Something to note is that Armando just said at the beginning of the presentation that right now we were adding additive blinding into the BOPRF construction. And BOPRF, this notion of adding public metadata, this new construction, does not work with additive blinding, because it's not only using the public key for the evaluation, but it's actually using a generator that is raised to the secret key plus the hash of the metadata. So it doesn't work for additive blinding, unfortunately. But it does work well with batching. We have even a proof of concept right now on Sage on the repository, also working with Sage and also working with BOPRF mode and OPRF mode. And with that, next slide. Yes, and I think that's all. I don't know if you want to add anything else, Armando.
I think it's fine. So we are open for questions, if any. Okay, we'll return the mic to the chair.
Okay, Sans, any comments? Okay, that's fine. Let's move on to the OPEC. Please, Chris, start.
All right, so this is just a quick update for Opaque. Should be significantly less than 15 minutes, I hope. So for those of you who don't know, Opaque was the selected asymmetric Pake from the Pake competition that was held recently. I forget exactly when. At a very, very high level. It basically takes a bunch of different cryptographic protocols and primitives and then stitches them together in such a way that you have an APEG that falls out on the other end. In particular, the two constructions that are most important are the OPRF, the protocol that Armando was just describing, and an authenticated key exchange protocol like Sigma or 3DH or what have you. And then there's also sprinkled throughout some other dependencies on things like hash functions, encryption algorithms, and so on. The protocol effectively runs in two phases. There's an offline registration phase, wherein the client basically takes their username password pair and sort of registers a set of credentials with the server, storing those credentials on the server. And then there is an online phase wherein the client uses its password to effectively recover the credentials, like recovering them, decrypting them, rederiving them, what have you, and then using those credentials and a mutually authenticated AKE, wherein they effectively demonstrate possession of the password. So if you know the username and password, you can run the login flow and authenticate. If you don't know that, you can't. That's effectively the gist. The document, because Opaque is so generic in terms of its shape and structure, you could really instantiate it in a number of different ways, using different OPRFs, using different AKEs. Rather than have a sort of collection of options, we decided to pick exactly one AKE and pin down a couple of different algorithms correspondingly to instantiate it. So this particular variant we call Opaque 3DH, and that is what's specified in the document currently. And there's some sort of text in the appendix which just describes if you wanted to move towards something more like Sigma, where you're using signatures rather than key shares to authenticate. Here's how you would do so, roughly speaking. And it also has accommodations for HMQB should you want to go down that route. TLS 1.3 being a Sigma-like construction as well is also applicable here. So between the last meeting and this meeting, some pretty substantial updates went into the draft. In particular, now there's this notion of sort of internal and external mode for the protocol, and this relates to how credentials or what credentials are actually input to the protocol and then stored on the server. In the external mode, a client brings to the protocol during the registration phase a public-private key pair that it wants to use for authenticating with the AKE during the online flow, and effectively encrypts the private key under a password-derived key and stores it on the server. In the internal mode, rather, what happens is that the username password pair is used to derive a public-private key pair during the online flow and then authenticate. And so these just differ in terms of what are the sort of assumptions about what the client has, what the interface looks like for implementations and so on. The internal mode is certainly much easier from an API perspective. You effectively don't need to know anything about the underlying primitives whatsoever. You can kind of just run Opaque and everything should work out of the box. But in circumstances wherein you have an existing, public-private key pair, or you want to delegate derivation of that public-private key pair to something that's perhaps FIPS validated or something, you could use the external mode. Another big change that kind of went in was to add mitigations for what we call client enumeration attacks. And an enumeration attack is where an adversary sort of interacts with the server in the online login flow to effectively try to determine whether or not a particular username has an account on the service or not. And depending on your use case, that may or may not be a problem. I mean, you can imagine if this were deployed in a web scenario, and adversaries trying to learn if a particular user has an account on example.com, trying to exploit this particular attack to learn that piece of information might be serious given the circumstances of what example.com actually is. So the protocol now accommodates that by basically making the server's response during the login flow effectively randomized, such that if you have the right password, you're able to sort of de-randomize the server's response and process it accordingly. If you don't have the right password, all you see are random bits. So the server's response leaks nothing about whether or not the username happened to be registered with the particular server. Of course, there's some obvious caveats here, like the timing side channels with respect to how long the server takes to actually compute the response are applicable and relevant, and the draft has some text and gives some guidance in terms of how to avoid those side channels. So implementations need to be careful with respect to how the server side response is generated, but in general, it's not too bad. And to help sort of validate that, this particular code path is tested, there are what we call fake text vectors in the document at the end, such that you can make sure that that particular code path is hit and working correctly. The last big change that we made was sort of in the AKE phase, the 3DH phase in particular. We used to have slots from the client to the server and from the server to the client for applications to sort of plumb in sort of arbitrary application specific info. You might think of this like extensions in the world of TLS. This was deemed sort of too complicated and also somewhat annoying because this meant that the key exchange messages for Opaque were no longer a fixed size. They depended on what the application input actually was. So to remedy this, we sort of extracted something from the SPIC2+ draft, wherein there's now just sort of agreed upon context string that client and server at the application layer sort of input to the protocol that's fed into the transcript and the key schedule used ultimately to derive the AKE output keys, but it's not included in the protocol messages sent over the wire, which has the same effect as allowing the client server to specify additional information for the AKE, but has the added benefit of not inflating or changing anything on the wire. So now everything is a fixed length during the AKE, and it's really quite simple to implement, especially if you use one of the recommended configurations. Along with sort of these major updates, there were a number of minor updates as well, documenting sort of what the trust boundary was between in receiving messages, potentially untrusted messages on the wire, what sort of validation you should do on those particular messages, and so on. Also alignment with the latest updates to the VOPRF draft to make the test vectors fall into place, and then just general, of course, editorial improvements. Or, we think they're improvements. They may not be actually. So next steps, I basically think we're at a point now where we consider ourselves to be feature complete. It'd be great if we had more implementations. We have some in Go, some in Rust, adding some in C and C++, especially if TLS stack integrations are a future trajectory for this particular protocol would be useful, built on OpenSSL, Boring SSL, what have you. There's also been requests for sort of Node or TypeScript, JavaScript implementations. So having sort of a pile of implementations that are safe to use would be great. At this point, we think we need just additional review, specifically review from the crypto review panel. And I've been discussing with the chairs what the procedure is in terms of making that happen. An action item for us, sort of, I guess, in parallel for figuring that out, is going through the reviews that came in during the paid selection competition and just making sure that there's no sort of outstanding issues that we have not addressed. But I don't think that blocks anything. And then I think after that, we're sort of ready to ship, unless there's any major features or blockers that people think we should add. So with that, I guess I'll pause and take questions.
Thanks a lot, Chris. I'd like to ask the first question. Could you please return to slide number 4? Could you tell a little more about the first minor improvement, explicitly about trust boundaries and possible communication or relation to the security proofs? Could you please tell more about this?
Yeah, sure. So the security proofs assume that all things sent over the wire are like valid group elements and so on. And there are particular sort of strange scenarios wherein an attacker might send a message over the wire that is effectively the identity element, for example, and cause the server to evaluate or effectively run the OPRF evaluation on the identity element, which definitionally means that the server's evaluation does nothing, and that would sort of allow someone who learned the output of the OPRF to run like a dictionary attack, because there's no private salt or anything integrated. So the text around here was basically to say, if you get something sent over the wire that was like the identity element, you just drop it on the floor and return an error, because by the spec, the client should never send the identity element as its OPRF message. So that's kind of what I mean about or kind of what I mean about the trust boundaries. So has no effect on the proofs. And in fact, if anything, it just brings it to closer alignment with what is assumed in the proofs.
Okay, thanks, I get it. And another question, do you or Hugo or someone wants to add anything to the existing security proofs? Because I understand that the draft is close to being sent to the chairs to us for the additional crypto review, panel review and for the last call. But if there are, maybe there is some advancement or some new research by Hugo or by someone in the sense of security proofs, or everything is done and nothing is left?
To my knowledge, everything is done. The only interesting bit is in the existing UC formalization for the opaque paper. The registration step is the registration functionality is not interactive. It just sort of assumes that the server creates like the client's envelope or the encrypted credentials honestly and like and stores it. Whereas in this particular protocol, of course, we use like an interactive protocol between client and server to run the OPRF to encrypt the credentials and store them on the server. However, there's some follow-up work coming that demonstrate that this particular variant is safe. So yes, I guess there is. If you just look at the opaque paper, there's more stuff to be done, but it's been done and it should be coming out anytime now.
Okay, thanks a lot. I think it's great work. Thanks for this. Any questions? Any comments? Going once, going twice. Some trees, and now Chris Wood with RSA blind signature.
Just I guess a quick question before we move on. So what are next steps for us for this particular draft? Is there anything like we should do in terms of like cutting a new version, or will the chair sort of confer?
The next obvious step is another crypto review panel review to check that all questions that were raised during the pack selection process have been addressed. And I think that we can start it very soon. So please let us discuss this with Alexa and Nick maybe next week or in 2 weeks. And then I think we'll start call for crypto review panel reviews. And then after that, we'll have some more questions. And after that, we'll be very close to research group last call, in my opinion.
Okay, great. Just wanted to know if it was an action on me or not. So I'll await your signal. All right, let's move on.
Yes, I'll grant. Okay, so Chris Wood, RSA blind signature status.
Right. Okay. So this is an update to the blind signature draft that was adopted last time. So as a reminder of what the protocol does and what it looks like, this is just your classic, blind RSA between client and server. The effective flow of the protocol is the client gets out of band the server's public key, and it has some message it wants to have signed to the server, but it wants to have that message signed in such a way that the server does not learn what the message is. So the client inputs server public key and message, runs some blind function to produce some output blind message and some inverse, sends the blind message over to the server. Server does some evaluation on that message, sends back a blind signature, and then the client finalizes or effectively unblinds and internally verifies that the signature is correct using the corresponding public key. And if all that works out just fine, then a signature pops out on the other end. Pretty simple, pretty straightforward. No state required on the server side, and of course there's state required on the client side between the blind and finalized steps. Since the last meeting, the biggest change has been sort of trying to deal with what the semantics of the encoding function are. There was a request to be able to support the full domain hash variant alongside the PSS encoding invariant, and our sort of response to that was to just support PSS, but allow the salt length to be 0, which is currently valid for PSS, wherein the salt length is a parameter. We added a test vector for that particular variant where salt length is 0. You still use the PSS encoding function. And we added some API guidance around, or API considerations around when you might want to use a deterministic variant versus a randomized variant. The sort of rationale for the deterministic variant is wherein you're in a scenario where you don't want the salt itself, the PSS salt, to be sort of a covert channel for messages that the server should not otherwise learn. So you fix that by removing the covert channel by making the salt 0 length. Alongside this update, we also improved some of the security consideration text. We went back and discussed with some others off list in terms of what the existing analysis told us about this particular construction, especially when using PSS as the encoding function. And we have quite high confidence that the analysis that Mihir and others did back in the context of FDH readily applies to PSS, and we've updated the text accordingly to match. And we've also done some editorial cleanup and made some sort of small changes to help interop be a bit more smooth. So for example, a recent change that was added was on the server side, when you get a message over the wire, that doesn't happen to be sort of a valid representative of a message that I can sign. So it's not an integer between 0 and n-1, where n is the RSA modulus. You just abort. The client, per the protocol, should never send such a message. So it seems fine on the server side to just abort. There have also been a number of different implementations that have been added, similar to HPKey. They're listed on the draft repository README. You can also click on the link if you have access to the slides to follow and see them there. There are 3 open issues remaining on the draft. I kind of think I rank these in terms of their contention, I guess. The first of which is increasing contention, I should say. The first of which is whether or not we should consider changing the name from blind signatures to something that's a bit more friendly from an accessibility sense. But after discussions with several people, both in the academic space as well as the editors on the draft, we sort of came to the conclusion that it's not used in a sort of pejorative sense. So that, and given its sort of strong connection to the literature, our proposal is to just sort of leave it as is. The second open issue is to whether or not we should extend this to support partially blind signatures. So it is possible to do this with RSA, but it's sort of funky. The basic idea is you sort of pin the modulus, and then from that you try to derive different public-private key pairs, different exponents E and D, under some certain constraint that each private exponent has a unique prime factor that is not shared with the other private exponents. So the process of finding this is sort of I guess ad hoc. You effectively input, you pin your modulus, and then you sort of try to search this space until you find candidate key pairs, and then you output them, and those become things. It's I guess problematic in that sense. Problematic in the sense that it's sort of atypical use of RSA, wherein you have a single modulus and then multiple different public and private exponents shared with it. But it's also sort of problematic from a performance perspective, because it means with very high probability that the public exponent is not going to be 3, which is typically done for performance reasons. You're likely going to have exponents that are significantly larger. So actually doing the RSA operations is going to take a much longer amount of time. In the issue 29, I did a quick benchmark to sort of demonstrate that this is indeed true, using the search algorithm that I found in the literature that does describe these for, finding these various public and private key pairs. So that the results are sort of discouraging. So basically, given that this is sort of awkward, not a common practice, it probably needs additional security analysis in terms of whether or not it's safe, given that the analysis was done sort of early 2000s. and it is bad performance. I can't remember if I said that already. I think the editors would propose that we just close this as well with no resolution. It's just not worth the complexity and the additional work, we think. The last open issue was to whether or not we should extend the scope, which was sort of a question raised during the adoption call, as to whether or not it should focus just on RSA blind signatures or try to rope in, or try to loop in other signature schemes like those based on ECDSA or Schnorr. However, given the recent attacks on blind signature schemes based on ECDSA and Schnorr, it seems clear that finding a safe variant of those is still very much an open research problem, and so it seems a bit too soon or premature to sort of try to fold them into this particular document. So the conclusion that we have for all three is to just close them out, and at which point I think the document will be in very good shape for research group last call or crypto review or what have you. Basically good to go.
Thanks a lot, Chris. I would share my opinion that I understand that the current status of analysis of RSA blind signatures made by Bilera and the previous works, the status is quite stable, so this is quite a mature set of results. In contrast to a lot of ECDSA and Schnorr-based blind signatures, where there are a lot of schemes that have been broken in a couple of years after being created. So, with my chair's hat off, I would support leaving this only with RSA blind signatures without addition any other stuff. But I'll be happy to see someone from the group to provide some preliminary review of the current draft, because it was only adopted this May or this April, and the draft is quite young, and I would like to have more people in the group seeing it, working with it. Daniel, yes.
Yeah, I agree. Any sort of feedback at this point would be great. We've had a number of reviews from people who have implemented it, and that's caught a number of editorial and sort of typo issues. But of course, any additional review would be useful.
Thanks. Daniel? Daniel, in the queue?
I can't hear you, DKG, if you're talking.
There we go. How about that?
Yeah.
Turns out the microphone has to be plugged in. You mentioned that you've got several implementations on a previous slide. I'm wondering whether you're testing those as interoperable implementations, and you also mentioned a few caveats like not responding to a peer that sends the identity element. Are you actively testing those implementations against those kind of gotchas?
So the identity element was in the context of the OPRF. I apologize if these all just sort of like fold
I'm sorry.
into one another. No, it's okay. For that one, yes, we are. For this one, Frank Dennis, one of the other authors of the implementations, I believe he's testing interop against all the ones that are available using the reference Python implementation that's in the draft and then his implementation. I can certainly confirm with him, but as far as I know, yes, they have all been tested for interop. Because the output is just like a signature that's verifiable with any PSS stack. So it's really just the can you produce given these inputs on the client side this expected signature on the output side.
Any other comments, questions? Okay, thanks a lot, Chris, for this, and new presentation from Chris. AAD limits. So the status of the draft 5+5. Please, Chris.
Okay. Yet another draft update. So this is the draft on specifying limits for authenticated encryption algorithms with Martin and Felix. Since the last version, there hasn't been a lot of change, though Martin did a lot of work in revisiting some previous papers and adding analysis for AADs that are useful or used in the context of TLS 1.2. Specifically, those AADs, GCM variants that don't do nonce randomization, as is done with TLS 1.3. Previously, we're just assuming that sort of, these blessed ciphers that we use for TLS and QUIC are those that we want to include in the analysis, but I forget where the request came from for the TLS 1.2 variant. Regardless, it was a reasonable request and Martin did the work to add it, so thank you, Martin. Also added some limits in the draft based on reasonable parameter sizes, like reasonable fixed length packet sizes, reasonable bounds for the advantage of whatnot. So if you're using this sort of document as a consumer, you just kind of want to know what is the constant that I plug into my protocol. Hopefully that table will help you. And then there was also some various editorial cleanup. In the next revision, which we hope to come soon, we're going to fix some issues that we both missed in the TLS 1.2 numbers. Felix, our resident expert, did a more careful pass than we did, and he has a PR up that we just need to land. They also did an analysis. Felix and some others did an analysis of Cha-Cha Poly in the multi-user setting, and are going to send a PR to the draft adding those limits alongside the GCM ones when it's available. So we're sort of waiting for that to come to sort of complement the existing GCM limits that we have. There are two open issues that are probably worth some discussion. The first of which is to account for the length of additional data that's included in the limits. We sort of previously just had made the simplification that this additional data was small enough that it was just overcome by the size of the plain text, and that's also been the pattern that's been taken by various analyses, in particular the one that we based our limits on 2018-993, sort of folds together the number of underlying primitive queries to be just basically the sum of plain text and additional data together. But in speaking with the authors there, particularly Stefano, it became clear that the amount of work to sort of separate these two out, it's not that much. And so we're going to work with him to hopefully see if we can split these two things up and get a bit more tighter limit expressed in terms of both the plain text size as well as the AAD size. It's unclear how we'll actually spell the PR and update the document, whether or not the main document will be written in terms of these two parameters, or this will be just an appendix or whatnot, because we want to, at the end of the day, be pragmatic and make this to be maximally useful for people who don't really understand, I guess, the technical details. So the less numbers and less parameters that are there, probably the better in terms of actually using it correctly. So the other issue is on SIV. There's a request to add it, and basically it's an action item that needs work. Given that it's not currently employed by any of the sort of major IETF protocols, sort of our conclusion would be to close this and punt it to a future draft. Should someone feel inclined to do that initial analysis, extract it from the relevant work and document it in the same sort of context that we've done here. Alternatively, we would very much welcome someone to contribute a PR that actually adds these limits on our behalf. We just haven't had the time to get to it yet. Quickly looking at the chat, thank you, Martin, for filling those. Yes, DKG was asking about adding OCB or EAX or any other modes, and yeah, if someone feels so inclined, we would greatly appreciate it, but we've just not had the time to get to it yet. So with that, once we sort of fix the existing TLS 1.2 numbers, add the multi-user Cha-Cha numbers, and then potentially add the variant wherein the AAD is separate from the plaintext parameter, We'll land those changes, close out open issues, cut a new version of the draft, and I think we're ready to move forward. Unless there are any additional features that people think, or things people think we should block on, but I think we're in good shape at that point.
Yep, with this, as with other drafts, we should take advantage of our crypto forum participants and get a solid review from them going forward. But I think that most of these things make sense. Is there anybody in the queue who has any comments about AEAD limits? If not, Chris, thank you for the presentations, and we'll move on to Michelle for a CPACE update.
Hi, everybody. So can you hear me fine or? Okay. So, so now I would just like to provide a quick update on the status of the CPACE draft. Actually, since the previous update in March, we actually have not made many changes to the actual draft. Most of the work has been done in updating the associated paper with the analysis of the security analysis of CPACE. And like just to remind you what CPACE is, so CPACE is the candidate that was selected by the Cfrg for balanced PAIC in the competition about a bit more than about a year and a half ago. And since then, I've been working with Bjorn and Julia on the secure analysis, in which we provide analysis, not only the basic version of CPACE, but the actual variants that are being implemented. So in particular, the current CPACE protocol variants, we've been able to show that they provide strong security guarantees. In particular, we've been able to show that they are securing the universal composability model, and they actually achieve adaptive security. Under a variant of the computational Diffie-Hellman assumption, is actually known as the simultaneous Diffie-Hellman assumption. And in the analysis, we also have been able to show, as Julia mentioned in the last meeting, instead of analyzing the map to point function as an ideal, as a random oracle, we actually try to separate that into the map to function from the hash of the password. So we actually, the way we compute the generator is a map to function of the hash of the password. The hash itself is modeled as a random oracle to a finite field, and the map to point functions actually modeled. We provide specific security properties for that. And we've been able to analyze, use that to analyze the particular instantiations of CPACE. So one thing that has become, that we try to clarify more recently has been the way we rely on the session identifiers. In particular, since we're working in the UC model, we assume that before CPACE starts, the application has to provide a unique session identifier to start the session, which is required for composability, for multi-session security, And this is a, so we try to clarify this now in the current version of the draft of the paper, which currently is under submission to AsiaCrypt. And in this new version, so we, as I said, beside the main change has been clarifying the role of the unique session identifiers. And we also used the opportunity to clarify the proofs, improve readability, and the security definitions. But regarding the session identifiers, I said that, which is, so they are required for composability guarantees. And because of that, they need to be added as input to all the hash functions that we use in our protocol. And they need to be established before running CPACE. So, and this is one of the issues that I think Feng Hao mentioned in his recent paper on ePrint. So regarding the session identifiers, first, there are several ways that if the application is not able to provide this unique session identifiers, there are ways that we can easily create such a identifier by first running a agreement between both parties involved in the protocol. So what is important here is that both parties should contribute with randomness to the session ID, but the session ID itself does not need to be private. But we need to make sure that both parties contribute to the generation of the session ID, so that the chances of having the session identifier not being unique is negligible. And since this is not private, sometimes there are ways to avoid adding the number of the round complexity of the protocol by piggybacking these messages to the messages sent by the application. So, but because this can certainly, I think, was one of the main complaints of Feng Hao in his paper, that this adds to the round complexity. One of the next steps that we're going to provide is actually a game-based secure analysis without the session identifiers. And the idea is that suppose now that you don't have these session identifiers are not available, will CPACE remain secure? And similar to the other Cfrg candidates like SPIC2 or JPEG, we can also provide a game-based proof for CPACE, which does not rely on the session identifiers. And in terms of guarantees, the guarantees would be essentially similar to that of the non-UC protocols. So in particular, like in the proof for SPIC2, we can provide a proof of weak forward security for CPACE if we don't consider the SIDs, and the assumptions used for this would be essentially that the same one that I used now in the proof in the UC version, and we would get perfect forward security if we consider the addition of key confirmations, the key confirmation step. And so, but this is something that we're currently working and still not done. But after we finish those parts, we're going to incorporate these changes into the RFC. So, but as I said, yes, session IDs can be more detailed. Perhaps this is one of sometimes when we provide the protocol that are secure in the UC environment, we always assume that these session identifiers are provided by the application and we don't pay too much attention to it. But I think one of the important points of the CPACE draft is to try to clarify the situation. So by that, that's why we want to make sure that we have a version of the secure analysis with and without session IDs. So I see that Watson has raised his hand, so I don't know if we, since this is the last slide, I guess we can just start the question phase.
Great, Watson.
Hi, Watson.
Thank you very much for your presentation. It seems that there's a broader issue behind the draft here, because during the PAKE competition, one of the main things that brought up was the importance of the UC proofs, and now we learn at the end that actually no, you can't implement and deploy it. We're going to use a game-based proof for the winner, and this depends on hash to curve as well. So do we need to reconsider the compass, realizing that okay, we actually need game-based proofs? We need to change the number of rounds to incorporate an SID if that's being used, or do we just go on and publish this? We understand that okay, it is what it is. I still support publication, but I think that raises a question about how we run this sort of contest in the future.
Regarding how to run the context in the future, I don't think I'm the most suitable person to answer that question, because what I can say is that I've been looking at the security analysis of all the candidates so far. So I was not involved in the RFC for SPAKE2, but I'm one of the designers of the original protocol, and we provided secure analysis for that, both in the standard model, in the game-based version, and the UC version. And even for the JPEG, we recently provided also analysis for JPEG in the game. I provided a few years ago in the game-based version, and more recently in the UC version. The point is, in terms of security, my feeling is that they all achieve a similar level of security. Perhaps you can use slightly stronger assumptions in one case or the other. So CPACE, you rely on the simultaneous Diffie-Hellman assumption. SPAKE, just on the strong Diffie-Hellman assumption. JPEG uses a version of the square Diffie-Hellman assumption, but these are those are all similar assumptions in the underlying group. In terms of session IDs, is a matter. If you want a security analysis with in the UC model, all of these protocols will require an additional that the application provides this unique ID, session ID. So it doesn't matter if we're talking about SPAKE2 or CPACE or JPEG. So they all would need that. And so if you consider UC security, you have more or less, all of them would need to provide this unique SIDs. And if you don't, they all can would not require it. So in a way, by providing this additional proof, game-based proof, is just to show that they all have a similar type of security. So I don't know if that's answer your questions. It's not really, I would not answer the question regarding the competition, because this is not, I was not involved in it.
Yeah, let's continue the discussion about the security primers on the list, and Chris Patton.
Yeah, so let me first say I'm a big fan of CPACE. It's a cool protocol. I am supportive of the idea of having game-based proof for both of the winners. I think that you brought up some practical reasons why this would be useful. I also wanted to suggest that we need to coordinate on the SID story across both drafts, I think, because I think this is theoretically an issue for both. I guess different camps of people disagree on what the SID means in the UC model, and like, you know, what does it come from? Does it come from the environment, or does it come from something else? But in any case, I think the story is theoretically the same, so I think there needs to be some coordination. Thank you.
I agree with that. Okay, Christopher.
Yeah, Chris Wood.
Yeah, just one, I guess one quick follow-up. Well, I mean, I'm not the UC expert, so certainly we talk with Hugo and others to see to what extent sort of the SID needs to be accounted for or coordinated with CPACE. But on the game-based proof requirement, Chris, were you suggesting that we also block opaque pending game-based proof?
I'm not suggesting we block on anything. Like, I think there's not going to be an attack in a game-based model against opaque. It seems really unlikely. I just think that I wouldn't block on it. I just think it's a really good idea for both protocols, not just CPACE.
I see. Yeah, I mean, it's interesting that the SID problem is not sort of manifested in the same way in the development of opaque, or at least I'm like completely oblivious to it if it has. So I don't understand why that is the case, but anyways, it's subtle enough detail it probably warrants further investigation discussion with Hugo and Michelle and others. So we can take it to the list or offline or whatever.
We can extend. We're ahead, so we can take one or two more people on the queue if anyone else has additional questions, and if not, we can move on. Thanks, Michelle. One note on this last slide here is incorporating changes into the RFC. It's not an RFC yet, so I would say into the draft. But yeah, thank you so much.
All right, thank you.
Thanks. So the last presentation here, and we are 10 minutes ahead of schedule, is a update on HPKE. I know we've had a earlier presentation about it, proposed extensions to HPKE. So Chris Wood, please take it away.
All right. So this should be fairly quick. This is just responding to an issue that Franciscus raised on the list. It's sort of an unfortunate issue. So as a reminder, HPKE has in it a number of different dependencies, one of which is a chem, one of which is a KDF, and the other which is an AED. And there is a registry created and maintained by this document for each different type of algorithm. We did not realize at the time that there exists already a registry for AAD algorithms that is already maintained by Anna. That is the first link here. And this was pointed out to us from Franciscus on the list. The registry that is already in there, or already on IANA, and that is in the HPKE document are somewhat different though. For starters, the HPKE registry requires that each algorithm specify the length of the key and the length of the nonce as distinct parameters. We rely heavily on these constants in the specification and the various functions used throughout. Also, importantly, HPKE's security analysis that was done by folks at INRIA requires, or assumes rather, that the AAD is IND CCA2 secure. And the AAD algorithms that are specified in this document, in the HPKE document, all meet that requirement. Whereas it's not the case for all the algorithms that are in the existing registry. So we'd like to sort of see if we can just, felt like bringing this to the group would be a good way to sort of resolve this particular issue or discrepancy. There are basically two paths forward. I mean, maybe more, but these are the two most obvious ones, at least. First of which is to just continue using the HPKE registry and use that indefinitely going forward. The second of which is to switch over to the existing registry, extend it with HPKE specific parameters, potentially adding in, fields indicating whether or not the algorithms are recommended or they meet the security the security bar, the IND CCA2 requirement that HPK requires. This is sort of problematic in that it would be a breaking change. In particular, the code points for AAD algorithms that are in that registry do not match that which are in the HPK registry. And in considering, all these things, it's a breaking change. You'd have to modify the existing registry and sort of decorate it with, what's safe for HPK specifically and what's not. Also, taking into consideration that I'm not aware of any uses of this particular registry, this existing registry. I guess that's probably not surprising considering that we just learned about its existence recently. But if people know about its use anywhere, that would be good to know. Basically, our proposal after speaking with the editors is to go with option 1, continue with the way things are, and just sort of ignore that this existing registry is out there. And that seems like it would be the simplest thing. Though I would like to hear what others think. Go ahead, Martin.
We have known about this registry for ages. I sort of assumed that the authors knew about this registry as well and had deliberately made a new registry because it is different. And that's not actually a terrible thing. The AEAD definitions in 5116 allow for a range of nonces, which I think is actually a pretty dumb idea, but they allow for a range of nonce sizes, and we have to have one for this one, and so on. And I think that this is probably the no change option is probably the sensible thing. And I don't just say that because I've shipped code that uses what's in the draft.
I wish I could say we knew about this registry, but oh well, mea culpa. So that sounds good. Does anyone else have any sort of strong opinions one way or the other? Because if not, I think we're just going to make sort of an executive decision and go maintain the status quo. Watson?
It just so happens you shepherded a document that depends on this registry, TLS 1.3. But I agree with what Martin's saying that we need our own things, and just about everybody does it, so there's no problem with making our own registry for HPKE.
Cool.
Chris Patton.
I was curious if there's a similar problem for the KDFs or the chems. Probably not, right?
I did look, but I did not see anything. That does not mean it's not there. But I mean, if we're going to stick with this, if the registries are similar to the AED one that we have here, and if we're going to stick with the HPK option, I imagine we would stick with the HPK options for those two algorithms as well, for similar reasons. I would be very surprised if there was a chem registry, given how new-ish that concept is in comparison to other algorithms that are using the IETF protocols.
Okay, thanks. And we have 10 minutes left in the meeting, so does anyone else have any other business? If not, we'll let everyone go on with the rest of their evening, morning, or afternoon, whatever time it is. Seems there's nothing. Thanks, everyone, and happy and successful IETF 111.
Thanks, everyone. Bye.
Is it over there? He left. Thank you.